Well, that's it. That's the quotient rule. Weird formula. Let's see an application. Let's see an example. So the example I'm going to give is pretty simple. I'm going to take the numerator to be just 1. So I'm going to take u equals 1. So now I'm differentiating 1 over v. The reciprocal of a function, 1 over a function. Here's a copy of my rule. What's du dx in that case? U is a constant, so that term is 0 in this rule. I don't have to worry about this. I get a minus, and then u is 1. And dv dx, well, v is whatever v is. I'll write dv dx as v prime. And then I get a v squared in the denominator. So that's the rule. Minus, I could write it as v to the minus 2 v prime. V minus v prime divided by v squared. That's the derivative of 1 over v. How about an even a sub-example of that? I'm going to take the special case where u is equal to 1 again, and v is a power of x. And I'm going to use the rule that we developed earlier about the derivative of x to the n. So what do I get here? D over dx of 1 over x to the n is, I'm plugging into this formula here, with v equals x to the n. So I get minus v to the minus 2. All right, if v is x to the n, v to the minus 2 is, by the rule of exponents, x to the minus 2n. And then v prime is the derivative of x to the n, which is n x to the n minus 1. Okay, so let's put these together. There's several powers of x here. I can put them together. I get n times x to the minus 2n plus n minus 1. One of these n's cancels, and what I'm left with is minus n minus 1. So we've computed the derivative of 1 over x to the n, which I could also write as x to the minus n, right? So I've computed the derivative of negative powers of x, and this is the formula that I get. If you think of this minus n as a unit, as a thing to itself, it occurs here in the exponent, it occurs here, and it occurs here. So how does that compare with the formula that we had up here? The derivative of a power of x is that power times x to 1 less than that power. That's exactly the same as the rule that I wrote down here. But the power here happens to be a negative number, and the same negative number shows up as a coefficient, and there in the exponent. Yeah? How did I do this? Sorry? Right. Where did that x to the minus 2n come from? So the rule, I'm applying this rule. So the denominator in the quotient rule is v squared. And v was x to the n. So the denominator is x to the 2n. And I decided to write it as x to the minus 2n. So the green comments there, what they say is that I can enlarge this rule. This exact same rule is true for negative values of n as well as positive values of n.